beg your pardon. Right, let's begin with arithmetic. In fact, we should know the cubes up to 20. 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is 216, 7 cubed 343, 8 cubed 512, 9 cubed 729, 10 cubed 1000, 11 cubed 1331, 12 cubed 1728, 13 cubed. Now I believe it's 2197, but I must be sure. So 13 times 169 is we need to do 2210, take 13, so we get 2197. Right, that's fine. And what do I say about uncertain results? Repeat 3 times. 13 cubed is 2197, 13 cubed is 2197, 13 cubed is 2197. Okay. 14 cubed is next. Okay, so we're going to do 14 times 200 to get 2800, and then 14 times 4 to get 56. So 2800 take away 56, it's 2744. 14 cubed is 2744. 14 cubed is 2744. 14 cubed, 2744. 2744. 15 cubed. So that would be 3375. 3375. Then, once you have those 5, put them together and recite through them. 1000, 1331, 1728, 2197, 2744, 3375, and again 1000, 1331, 1728. You see? Catches you out. Alright. Mm-hmm. 2197. Right, we'll begin again. 1000, 1331, 1728, 2197, 2744, 3375. And now by digits. 1000, 1331, 1728, 2197, 2744, 3375. And now go backwards. 3375. See? You've got to have that flexibility. You've got to go backwards now as well. Okay. 3375, 2744, 2197, 1728, 1331, 1000. And now again. 3375, 2744, 2197, 1728, 1331, 1000. And now by digits. 3375, 2744, 2197, 1728, 1331, 1000. Okay. All right. So we're ready now for set 7. Set 7. And that is 45 times 16. 45 times 16. That's the same as 90 times 8, which is 720. 85 times 12. 85 times 12. Alright, that's 1020. 65 times 24. 65 times 24. So that's 130 times 12, which is 1560. 125 times 88. That's the same as 1000 times 11, which is 11,000. 1250 times 48, which is the same as 10,000 times 6, so 60,000. 2 times 49 times 50 is the same as 49 times 2 times 50, which is 49 times 100, which is 4,900. 5 times 23 times 20 times 3. Rearrange to put the 5 and 20 next to each other, so it's 100 times 23 times 3, which is 100 times 69, which is 6,900. 8 times 13 times 125. Rearrange to get 13 times 8 times 125, which is 13 times 1,000, which is 13,000. 12 times 25 times 7 times 4. Rearrange to get 12 times 7 times 25 times 4, which is 12 times 7 times 100, which is 84 times 100, which is 8,400. 625 times 9 times 16. Now, 625 times 16, well, you have to recognize that 100 divided by 16 is 6.25%, right? Okay, so 625 times 16 would be 10,000, or rather 100,000, 100,000. So it's 100,000 times 9, so 900,000, 900,000. Okay, next up, we have division here, division. 693 divided by 21. 693 divided by 21. Okay, so first divided by 7 and then divided by 3. 693 divided by 7 is 99. And that divided by 3 is 33. 1176 divided by 24. Okay, so divide them both by 2. So we get 588 divided by 12. And then again, so we get 294 divided by 6. And this we can now do because we know that it's 49. (2,574) divided by 18. 2,574 divided by 18. So first divide it by 2. So we get 1287. 1287 divided by 9. And then divide that by 3. So we get 429 divided by 3, and then divide that by 3, so we get 143, 143. 3,528 divided by 56. 3,528 divided by 56. Okay, we can divide this by 7. Notice that we have 35 and 28. So we say 704 divided by 8. 704 divided by 8. Now 704 is very close to 800, which would be 100 times 8, but it's 96 away from it. So we think 8 times 12, well, that's 96. That's 96. Okay, so we do 100 take away 12 to get 88. And now 12,168 divided by 72. 12,168 divided by 72. We're going to divide them both by 8. We're going to divide them both by 8. Okay, so 168, that's fine. That's just 21. 21. But what about 12,000? Well, 12,000, that would be 1,500. So 1,521. And that has to now be divided by 9. It has to be divided by 9. 1,521. Okay, so let's see now. Oh, I see it. So we have 169 as the result. 4,350 divided by 5. Instead, make both of them twice as big. So 4,350, that would be 8,700, and then that has to be divided by 10. So we knock off a 0 and we get 870. 8,600 divided by 25. Divided by 25. Well, how many 25s go into 100? The answer is 4. How many 100s go into 8,600? The answer is 86. So really, you have to do 86 times 4. And to do that, you double it and then double it again. So we get 172 from doubling it once, and then we get 344 from doubling it twice. $21,000 divided by 125. How many 125s go into 1,000? The answer is 8. How many 1,000s go into 21,000? The answer is 21. So the answer is 8 times 21, which is 168. 46 divided by 0.25. Same sort of logic. We have to just multiply 46 by 4. Double it to get 92, and double it again to get 184. 37 divided by 0.125. How many 0.125s fit into 1? The answer is 8. So 37 has to be multiplied by 8. And when we do that, we get 296. Okay, and next we have this, which I've never seen before. 36 over 48 times 32 over 54. Okay, so that's the same as 3/4 times 16 over 27. 3/4 times 16 over 27. But we shuffle things around. So we get 16 over 4 times 3 over 27. Now 16 over 4 is just 4. And 4 times 3 over 27, well, that's 4 times 1 over 9, so 4 over 9. 4 over 9 is the answer. And this is very small text. 21 over 40 times 64 over 49. 21 over 40 times 64 over 49. Okay, so that's the same as 21 over 49 times 64 over 40. Which is 3 over 7 times 8 over 5. Which is 24 over 35. Which is complete. $125 over 216 times 72 over 25. We move stuff around, so it becomes 125 over 25 times 72 over 216. The first reduces to 5. 72 over 216 is 1/3. So it's 5/3. Okay, that says 98 over 121 divided by 49 over 33. So it's 98 over 121 times 33 over 49. So it's 2 times 3/11ths, so 6 over 11. $169 over 84 divided by 91 over 36. So that's 169 over 84 divided by 36 over 91. So that's 169 over 91 times 36 over 84. The first one turns into 13 over 7. 13 over 7. And then that turns into 3 over 7. 13 over 7 times 3 over 7. So that's 39 over 49. 39 over 49. Well, it seems so anyway. 66 squared. 66 squared. 4,356. 6,666 divided by 22. 303. 222 times 45. 222 times 45. Alright, that's the same as 111 times 90, which is 9,990. 1,111 squared. Okay, so we know that the pattern of digits would be 1, 2, 3, 4, 3, 2, 1. So that's 1,234,321. 37 times 81. 37 times 81. Now, we could do this But let's think about it in a different way. 37 times 3 is 111. 111. Okay, well 81 divided by 3 is 27. So it's 111 times 27, which is the same as 999 times what? 3. 999 times 3. So you multiply 3 by 1,000 and take 3 away, and we get 2,997. Okay, so it says right, I don't know what that language actually, what that actually means. Presumably it means the remainder, but I have to actually check that. Alright, just give me 1 second while I check what this means. It says find the residue of 777,777 modulo 9. I'll just say find the residue of 7 modulo 3. Oh yeah. Alright, so it's just a fancy way of saying what's the remainder. Okay. Find the residue of hello. Find the residue of 777,777 modulo 9. Now, what I'm interested in is what the digit sum sort of means here. Okay, so we can just go ahead and perform the division. And when we do that, we get 8 and then 5 left over. And then six and 1 left over. 1 and 8 left over. 9 and 6 left over. 7 and 4 left over. So we believe the answer is 4. But if we add them up, we get 42. And that has no relation to it. So I don't know how to actually compute that. No, I don't know what the connection is. Okay, so that's great. So we'll explore that on a different date. Because for now, we're going to go back to who? JMC. So we're going to go to set 8. For how many positive integers n does 180 divided by n leave a remainder of 5? Okay. So 180 divided by n is such and such, remainder 5. Well, if that's the case, then we need to think about the multiples of, rather the factors of 175, right? And what is 175? Well, it's 25 times 7. So for 1 it doesn't work. 5 it doesn't work. Or 7. It does not work. But for 25 it does. And what about for 35? Yes, it works. And what about for 175 itself? Yes, it works. So it works for those 3. So for how many positive integers n does 180 divided by n leave a remainder of 5? It appears to be 3 numbers, and they are 25, 35, and 175. Which of the following numbers leaves the same remainder divided by 3 as divided by 4? And the numbers are 7, 11, 17, 19, and 25. So we can go through them one by one. 7, it does not work. For 11, it does not work. For 17, it does not work. For 19, it does not work. It only works for 25, but they leave a remainder of 1. So we were asked which of the following numbers leaves the same remainder when divided by 3 as divided by 4, and the numbers were 7, 11, 17, 19 and 25, and we believe the answer is 25. What is the smallest sum of two two-digit numbers using 4 distinct digits? We have to minimize the sum, so we're going to make the tens as small as possible. And in that case, it will be 1 blank plus 2 blank. Now we have to minimize the units. So it doesn't really make a difference which way we do it. For example, it could be 10 and 23 or 13 and 20. But the answer is surely 33. So we were asked, what is the smallest possible sum of two two-digit numbers that can be made using 4 distinct digits? And we believe the answer is 33, as created from 10 and 23. On Lee's 16th birthday, Mel was 3 times the age of Lee. How old is Mel on Lee's 21st birthday? So Mel is 48 on Lee's 16th birthday. And the gap between them is 32 years. So on his 21st birthday, Mel will be 53 years old. So we were told that on Lee's 16th birthday, Mel was 3 times the age of Lee, and then we were asked, how old will Mel be on Lee's 21st birthday? And we believe that the answer is 53 years old. How many digit pairs P, Q make the 5-digit integer P869Q a multiple of 15? P869Q. Alright, so first of all, Q has to be 0 or 5 because it's a multiple of 15. And second, the digits have to add up to a multiple of 3 to be a multiple of 15. Okay, so if Q is 0, then we have P869, 0. P869, 0. And 869 adds up to 23. Right? Yeah, it does, yeah. Okay, so P can be 1 to get 24. Or P can be 4. Or P can be 7. So 1, 0, 4, 0, 7, 0. Those are all valid. Those are all valid. Now if Q is 5, then we have P869, 5. And 8, 6, 9, and 5 add up to 28. But we need a multiple of 3. So in this case, P can be 2, or 5, or 8. So we have 1, 0, 4, 0, 7, 0, 2, 5, 5, 5, 8, 5. And we have 6 combinations. So we were asked how many single digit pairs P, Q can satisfy P869Q, where P and Q are single digits and P869Q is a multiple of 15, and we believe that the answer is 6. For digits P, Q, and R, the 2-digit numbers PQ and PR sum to 75. Find P plus Q plus R. Yeah, that's right. Are you sure? Yes, that's right. That's right. That's right. Alright, if that's the case, then P obviously has to stand for 3. Now, for example, you could have 38 and 37, but you could also have 39 and 36. But it's fine either way. The point is, Q and R have to add up to 15, and P has to be 3. So P plus Q plus R has to equal 18. So we were told that P, Q, and R stand for 3 single digits, and we were told PQ and QR add up to 75, and then we were asked what is P plus Q plus R, and we believe the answer is 18. Approximately how many times longer is a 7,821 kilometer highway than a 2.06 meter street? 7,821 kilometers is 7,821,000 meters. And we have to think. You know, we could just do the division, but is there anything more to this? No, I don't think so. I don't think there's anything more to this. No, that's fine. That's just a division problem. Counting from 1 and omitting multiples of 3 and 5, what is the 15th number said? So we can just proceed directly. 1, 2, 4, 7, 8. 1, 2, 4, 7, 8 are the first 5. Then 11, 13, 14, 16, 17. So that's the next block of 5. 19, 22, 23, 26, 28. Okay. So if we count from 1 and we omit multiples of 3 and 5, then we believe the 15th number that you're going to say is 28. If 80% of a route is 1,200 meters longer than 20% of it, what is the length of the route in meters? So let the length of the route be L, then 0.8L is equal to 0.2L plus 1,200. So 0.6L equals 1,200. So L is equal to 1,200 divided by 0.6, which is 12,000 divided by 6, which is 2,000 meters. So we were told that 80% of a route is 1,200 meters more than 20% of it. And we were asked to find the length of the route, and we believe the answer is 2,000 meters. How many integers from 1 to 150 are multiples of at least 2 of 3, 5, and 7? Okay, so, well, we should first figure out 3 times 5 times 7. And 3 times 5 times 7 is 105. So we knock that one out straight away. Okay, and then we have all the multiples of 15, all the multiples of 35, all the multiples of 21. Now we have to exclude 105 from those. Do you see? Okay, so for 15, that's kind of simple. That's just 10. But then we have to take away 1, so we get 9. That's fine. Then for 21, we have 6 additional ones. Then for 35, we have 3 additional ones. So it's 1 plus 9 plus 6 plus 3. Bringing the total to 19. So how many numbers from 1 to 150 are multiples of at least 2 of these numbers, 3, 5, and 7? We believe the answer is 19. Okay. Next up, we have set 9. Set 9. A school of 600 pupils has 30 more girls than boys. Find the total number of girls. Now, we believe that the answer is 315, because 315 and 285 is 600. So in a school of 600 pupils where it has 30 more girls than boys, the number of girls is 315. How many of the following are perfect squares? 1 cubed or 2 cubed, the sum of the first 3 cubes, the sum of the first 4 cubes, or the sum of the first 5 cubes? So we know that they're all perfect squares, because the sum of the first n cubes, the formula to calculate it, involves getting a perfect square. So all of them. So we were asked how many of the following are perfect squares, and they said to us the sum of the first 2 cubes, the sum of the first 3 cubes, and then the sum of the first 4, and then the sum of the first 5 cubes. And we say the answer is all of them. Hello. Find the last digit of the smallest positive integer whose digits sum to 2019. To force it to be the smallest, as small as it can possibly be, we're actually going to have 9s in all the digits except for the units digit. So how many 9s go into 2019? Well, some amount, and then the remainder is 3. So the answer is 3. So find the last digit in the smallest integer whose digits sum to 2019. We believe the answer is 3. Hello. How many equilateral triangles have 3 vertices of a cube as their vertices? Now, I'm not sure what they mean by this. Because it certainly doesn't work when you're talking about the faces of it. And in fact, I wouldn't say that it works for any of it. So I would actually say none, but perhaps I misunderstand the question. Restoring an engine costs £4 million, roughly 500 times its build cost. Find its build cost. You just have to do £4 million divided by 500. And the way to divide something by 500 is first you divide it by 1,000 and then you times the answer by 2, so it'd be 8,000. £8,000. So we were told that the cost to restore an engine was roughly £4 million, which was 500 times its build cost, and then we were asked its build cost and we said £8,000.